Hello, it's Keith from Kinvert doing another one with ChatGPT here, solving CIFAR-10. So the first time I tried, I got logged out for some reason. This is the second time, and this time it actually went a little bit more in depth with trying to train to better accuracy. So I'll quick go over the code and the chat and everything. If you find this helpful, please leave a like, or if you have any questions, leave it in the comments. So I basically just asked it to solve CIFAR-10 to 85% accuracy using TensorFlow 2.8, which is what I have, and I have a 3070 Ti. And I specifically asked it for no explanation because when it does that, it can take a lot longer to get it to finish, and sometimes you'll get like network errors if it takes too long. And so it kept the explanation nice and short, and I just copied the code and dumped it straight in, and that's what it's training on now. And let's see where we're at. So we've still got some time, so I can explain the code here for you. So basically it's using TensorFlow. Now last time it did Kira's dot layers, etc. This time it just imported Kira's and did it this way. We're taking in the xtrain, ytrain, xtest, ytest, and that's coming straight in from here. You can also do MNIST. I believe they also have CIFAR-100, and they actually, I think, have quite a few other data sets as well. And then what we're doing is we're normalizing this data. It comes in between 0 and 255. Like that's a way that, for example, OpenCV likes it. But when you're training a neural net, you usually want those values between 0 and 1. And so that's what this is doing. It's just normalizing that down so that their float values between 0 and 1. These are the layers. So there's 32 kernels that are 3 by 3. They're at first started randomly, and then these will train. Padding is same on this. And then the input shape. So the input shape, this is, so for MNIST, it's 28 by 28 by 1. So that is a single channel image. It's grayscale. This is a slightly bigger image. And then it's also got 3 channels. It's got RGB. So these are color images. And then it's doing the batch norm here, and then more conv layers, and then it's doing the, well, just one more there. And then the max pooling. So this is basically shrinking the image in half effectively. And what it's doing is it's taking a 4x4 area and saying which of these pixels has the highest value, and I'm going to keep that one, and then it makes an image that's half the size. There's other good videos that explain that in depth. I'm not going to do that now. And then you can afford to have more kernels as you go on, because this is where it's most computationally expensive when you have a very large image, although in this case it's not particularly large, but that's part of the reasoning for it. And the other is you're starting to get more actual kind of information down here, and you can look at some of the visualizations of how convolutional neural networks actually train and what they see. I'm not going to go into that in depth now either. I'm trying to make like a 5-minute video, and yeah, I'm on track for that. The dropout is, it's a way to kind of regularize and make sure that you're not overfitting on your data. And so what that's doing is kind of ignoring, in this case, 30% of the weights, and not training on those at this time. And so that is one of the ways to regularize, and it's one of the quicker, easier ways, in my opinion. There's also L1, L2, and other things. In the end, it's doing the flatten, because this is coming in, let's see, so it's 32, 16, so this is an 8 by 8. And so this is going to flatten this down to a 64, and then it's doing a dense. And so it's going to have a kind of a dense connection between this 10 and the 64 above. And I could do a model summary to show you that. So this is done, and sure enough, we got 85% on 100 epochs. So model.summary, it should be, yeah, it's called model. And so here's those layers, and you can see that, was I dumb and I said 8 by 8 when it's, oh, it was 8 by 8, but then it gets down to 4 by 4. And so now this is a 16 when they flatten it. And then there's, why is there so the 2048 is because it's also looking at all of these kernels that are coming in, and then they're going by this. And so we're using 300,000 parameters, and a lot of it is right here. That's quite a bit of it. And that's looking like the biggest one, and I would guess it's the biggest one, yeah. So yeah, this is the biggest one as far as the number of parameters in there. But yeah, this is the code that ChatGPT sent. This is all I asked, and it literally solved it for us here. That's the model summary. But the big thing here is this isn't a great accuracy, honestly. And last time that I trained it, it actually did better, but it took too long, and it logged me out, and I lost the video. But well, I didn't lose the video; it just logged me out. So, but yeah, pretty cool. ChatGPT just solved this for us in less than 5 minutes here, and literally all I had to do was directly ask it to do it. Now, for more complicated things than this, it does take a lot of help. If you look at my other videos, you'll see a lot of times I've got to be quite hands-on to keep good results. Sorry for the noise. And so I wouldn't worry so much about this getting people laid off. I mean, really, to me, this is a tool that can help outline your code, and then you can sit there and make changes you need. Because, for example, 85%, that's just not accurate enough for me, to be honest. I would want more accuracy, and I would have to come in here and make some changes. So, yep, Keith from Kinvert. Hope that was helpful and interesting, and I will see you guys in the next one. Bye.